Hello, this is another Igcse chemistry tutorial, and since we've come to the end of pretty much the most, at least, if not all of the theory that you need to know for energetics, let's do a question that you can find from the book to sort of establish uh, that we definitely know what we need to know. And by all means, if you want to stop the video right here and do the question, try it yourself, and uh, continue once you're done to check your answers. That's fine. Or just if you're here for the way of thinking that you should have to approach these questions, that's absolutely fine as well. So let's start. Okay. So let's read the question. When 5.15 grams of lithium chloride is dissolved into 50 centimeters cubed, 50 milliliters of water, the temperature of the sodium of the solution goes from 17 degrees Celsius to 33.5 degrees Celsius. Calculate the heat energy released in this experiment. Specific heat capacity of water is 4.18 joules per gram per degree Celsius, and given that 1 centimeter cube of the solution equals to 1 gram. Okay, so let's start. Okay, question 6a. Actually, before we start, there are a couple of things that we need to realize. Okay, so first of all, the question tells us that once the lithium chloride is dissolved into the water, the temperature of the water, of the solution, rises from 17 degrees Celsius to 33.5 degrees Celsius. And we measure that, of course, using a thermometer. And if you remember well, from the beginning of this short series on energetics, when we notice that there is an energy change that is positive, there is a temperature change that is positive, so energy, the energy measured rises, that means that the system is losing energy, and that is experienced by the surroundings, which the thermometer is very much part of. So this is an exothermic reaction. This is better explained in the first video of this short series. So if you're having trouble with this, go back, watch this, and come back after you finished. Now, obviously, we know that the specific heat capacity of water is 4.18 joules per gram per centimeter per degree Celsius. Sorry, that is something you absolutely need to know. Most of the time, they will give it to you in the question, but in case they don't, you need to remember it. And also, they tell us that 1 centimeter cube of the solution is 1 gram. Now, this is absolutely true for water itself, for pure water, but here we have a solution. So some of you will probably say, well, actually, it's not that, because by adding lithium chloride to it, we have changed it. So we have changed this ratio, and it's not absolutely that. But actually, this is a generalization we're allowed to make at IGCSE, so we'll go with it. Okay? And the first question asks us to find the change in the heat energy released. And if you remember, we'll need to use this equation, Q equals to mc delta T, where Q, of course, is the energy change, m is the mass, C is the specific heat capacity, and delta T is the change in temperature. M, in this case, well, that's another interesting part, okay, because we're given two values for the mass. We're given the 50 centimeter cubed of water and the 5.15 grams of lithium chloride. So some of you will say again that well, it's more complicated than it appears to calculate the mass of this solution. But again, for the purpose of this question and for the purpose of the IGCSE syllabus, we're just going to use the 50 centimeter cube of water, and this 5.15 grams of lithium can be ignored in this question. So, given that we've got 50 centimeters cubed of water, and that 1 centimeter cube is equal to 1 gram, we have 50 grams. The specific heat capacity we're being told is 4.18 joules per gram per degree Celsius, and the delta T equals 33.5, which is the final reading, minus, or the largest reading in any case, minus 17.0, which is the initial reading. And this, if we compute that, check with your calculator, but this is equal to 16.5 degrees Celsius. And to compute Q, we multiply all these values together, so what we're doing is 50 times 4.18 times 16.5, which, check if you want, but gives us 3,448.5 joules. But if you stop here, you'll get the marks for the working you've done here, but you won't get the marks for the final answer, because this is an exothermic reactions. And for exothermic reactions, because energy is leaving the system, we must absolutely write that this is a negative change in energy being transferred, because energy is leaving the system, is not entering the system. And you are encouraged most of the time to write this in the form of kilojoules rather than joules. And in this case, this is equal to negative 3.449 if we simplify it, kilojoules. And this is the final answer. Let's move on to question B. With B, we're asked calculate the amount in moles of lithium chloride dissolved in a solution. So you see the pattern here. They're asking us for the energy change here and the number of moles here. So maybe we'll have to do something with these two values later on. So B, we know that the number of moles, N, equals to the mass of the substance divided by its molar mass. In this case, to find the number of moles of lithium chloride, we have the mass of lithium chloride, which we're told is 5.15 grams, over the molar mass, which if we calculate, check with your periodic table, but this is 42.394 grams per mole. And if we compute that, once again, do check with your calculator, but this is equal to, when we simplify, it's equal to 0.121 moles. Great, so this is our final answer for B. Let's move on to C now. Using your answers from A and B, so we were right before, from A and B, calculate the enthalpy change when 1 mole of lithium chloride dissolves in water in kilojoules per mole. So we know that when 0.121 moles of lithium chloride are dissolved in water, there is a change in temperature, in energy, which is 3.449 kilojoules. So to find what happens when we have 1 mole of that, we're going to divide, to find delta H in other words, we have Q, the energy change, over the number of moles, N. So in this case, we have negative 3.449 kilojoules. These units I'm just putting here to establish that what we're talking about is the enthalpy, is the energy and the number of moles. You don't have to write them down. Actually, you don't need to, so keep that in mind. And the number of moles is 0.121. If we calculate that again, check with your calculator, but this gives us roughly negative 28.5 kilojoules per mole. So by this we mean that when 1 mole of lithium chloride is dissolved in water, the enthalpy change will be negative 28.5, and of course negative again because the reaction is exothermic. Now let's move on to D. D tells us the data book a data book, gives a figure of negative 37.2 kilojoules per mole for the heat release when 1 mole of lithium chloride is dissolved in water. So just two reasons why the value calculated in C might be different from the value given in the data book. Now, what happens here is that basically you're being told that this value you calculated in part C is too small, and the actual figure is negative 37.2. Now, don't be discouraged by this. These are questions they love to ask, and most of the time they give you values that are quite a bit lower than the actual value, deliberately, so that they can ask you this question. And this is a question they like to ask a lot. So we need to think of reasons why the change in energy that we calculated and that was recorded using the thermometer was not as great as it should have been. And there are a few reasons for that. I'm going to write more than two so that you have all the scenarios possible. So one of them, which you can answer pretty much all the time you see these questions, and it's going to be right. You're going to get the points most of the time. Is that energy is lost to the surroundings. Energy lost to surroundings. Of course, when we have a beaker, I'm going to draw the diagram over here at the top. We have a beaker and we put a thermometer in it, and we have the solution. Some energy will be lost in the surroundings quickly and will not be able to record this change in temperature using the thermometer. So that seems logical that if a smaller change was noted, then the final result will also be smaller than it needs to be, than it actually is. A second scenario might be that energy is actually absorbed by the container in which the reaction is taking place in. So energy absorbed by container. So energy being absorbed by the beaker, in other words. Third one could be that the dissolution of lithium chloride is incomplete. So yes, you put 5.15 grams in the water, but how do you know that all of it has been dissolved? So incomplete dissolution. And if only part of it has been dissolved, obviously the change in energy will be smaller than what we expect, or than what actually happens. And the fourth one, now this is a bit of an ambiguous one, because some mark schemes will take it as right, some will not. But if you have nothing else to say, maybe you can take a risk and write this down. Is that maybe not all the lithium chloride weight on the scale was correctly transferred into the beaker, and maybe some of it was lost, some of it was dropped, some of it, I don't know, just wasn't put into the system, and thus we still have less lithium chloride being dissolved, and the change in energy is smaller. I do not recommend that this is one of the two reasons you write down, because again, it's an ambiguous one, and I don't like it personally. But if you're stuck, it's a good little trick you can try. And this is the end. We finished this question, and I think this also is the end of the energetics topic. We may do some tutorials using exam-style questions taken from my GCSE past papers later on. But as for the theory of it, this is pretty much it. So look out for next videos on different topics, maybe organic chemistry, inorganic chemistry, and that's it. So well done and goodbye.